Hey guys, welcome to Linear Algebra. In order to get the most out of this course, you're going to have to read very carefully, try every single problem, and do not assume because you've seen it in algebra that you should skip over it. What we're going to do is we're going to start with chapter 1, which is the systems of equations, and this is going to seem rather easy, but again, you want to watch for vocabulary. You want to try every problem and so on, okay? So I'm going to begin with this. A linear equation in two variables, x and y, can be written as a1x plus a2y equals b. Now, what you'll notice here is that x and y are both to the first power. We also want to note that a1, a2, and b are constants, okay? The second thing, a linear equation in three variables can be represented by x, y, and z, and some of you have already seen this. Once again, x is to the first, y is to the first, z is to the first, and a1, a2, a3, and b are constants. But what if we had n variables? Many variables, even more than 26. You don't want to sit there and say x, y, z, a, b, c, and so on. So what we can do here is we can represent x1, x2, this is like our y, this is like our z, and so on. a1, a2, a3, an, and b are still constants, but x1, x2, x3 now is what we will be using as our variables. So this is if we have n variables, okay? So I hope that makes sense. These three are going to be linear equations, okay? And the reason why is, once again, this is to the first, this is to the first. This is to the first, this is to the first. This is just a number. This is just a number, right? They're constants. Sine of pi, everyone, is just going to be 0. And so this is still to the first power. And so therefore, all three of these are linear equations. Okay, so take a look. One of them is x and y. This is x, y, and z. And then if we had n variables, once again, we want to change letters. So we have x1, x2. This is not linear because it's a product. This is not linear because it's exponential. This is not linear, it's trigonometric. These three are non-linears, okay? If I go too fast, pause the video. Let's talk about a solution and a solution set. A solution of a linear equation in n variables is a sequence of n real numbers, s1, s2, s3, all the way to sn, that satisfy the equation when you substitute the values. x1 equals s1, x2 equals s2, xn equals sn into the equation. So let me show you an example here. Imagine I have x1 plus 2 times x2 equals 4. Well, if I made x1 equal to 2 and x2 equal to 1, wouldn't that satisfy it? Sure. What if I made x1 negative 4 and x2 positive 4? Negative 4 plus 2 times 4, that works, right? What if I made x1 0 and x2 2? That works. So there's a bunch of solution sets, right? So the set of all the solutions of a linear equation, it's its solution set. And when you have found this set, you have solved the equation. So once again, the set of all solutions of a linear equation, is its solution set. And when you found the set, you have solved the equation. So to describe the entire solution set of a linear equation, what we're going to do is going to use parametric representation. So a lot of times when we think of parametric, we think of the variable t. And here's basically what's going to happen, okay? We have, let's say this example, x1 plus 2x2 equals to 4, right? Now, just like we've seen here, there's many answers. What you can do is you can take the last variable, and you should, that's just conventional, right? And what we can do is we can say, I'm going to go x1 is equal to 4 minus 2x2. And what you're going to do is, it's almost like saying y equals 4 minus 2x. And what happens here is we're going to call this person the free variable. That means you're allowed to put any number you want in there. Okay? It's the independent variable. It's the free variable. However, whatever number you put in here is going to have an impact on this number. So this person is not free. It's dependent. Okay? So what we can do is we can say, let x2, this variable, equal to t, and then let x1 equal to 4 minus 2t. And what we did there was we represented it as a parametric. And then whatever you choose for t, let's say you want t to be 0, right? So that's x2. Then x1 will be 4 minus 2t, which is 4. So basically based off of whatever you want t to be. So if t was 1, then x1 is going to be 2. And that way it's much easier to come up with the solution. Some of you might say, well, what if we had 3 variables, like 3x plus 2y minus z equals 3? Well, what you're going to do in this case is move 2 of the variables on the other side. So I'm just going to move these 2, minus 2y minus z. You're going to make y and z. I hope that makes sense, that you have to make both of them free variables. So we're going to make, let's say, y we can call s, and z we can call t. And therefore, x can be represented, basically if I divide by 3, here, x can be represented as y minus 2/3 s minus t over 3, or 1/3 t, right? And then we're going to say that this is my parametric representation. And then basically what you would have to do is you would have to assign y a value or s a value, z a value or t a value, and then it will force x. So these two are the free. So I'm going to stop here for this video because I don't want to make it too long, but come back for the continuation of chapter 1, section 1 of linear equations, or linear algebra rather. Have a great day.